So now we will see the result of our simulation. So first of all, go to graphics and animation, go to contour. We want to see the temperature distribution for the combustion. So first of all, we have to create a plane at the center of our domain. So go to new surface, isosurface, and go to mesh, x coordinate, compute. So you can see the mesh range. So iso value 0 will create a center plane. So name it center plane, create, close. So select this center plane, select the temperature, static temperature, and display. Now change the level and check the field option, and here you can see the temperature distribution. So here you can easily see the combustion process is going on, and the maximum temperature is around 2300 degree Kelvin, which is the adiabatic flame temperature of methane. So change your display, go to display, go to option. In the color map, change it from left to bottom, apply, close it, go to display, color map, change the type from exponent to float, apply, skip, change it from 3 to 15, apply, so that you can see the temperature clearly, close it. Now you can see very clearly the temperature. Now if you want to see the velocity, so select the velocity and display. You can see the jet velocity of our methane air. If you want to see the pressure, you can see the pressure here. But the most important thing is the species. So go to species, and here you have the mass fraction of your species. For example, if you want to see the mass fraction of oxygen, select this and display. You can see the mass fraction of oxygen. So here at this edge, this is the air inlet. So here you have lots of air. So here you have lots of oxygen. You can see the mass fraction, maximum mass fraction of oxygen is 0.23. So here you have maximum oxygen, but as the reaction goes, the oxygen is being consumed and it will create carbon dioxide and water. So there will be no oxygen anymore, which is kind of makes sense with this contour. If you want to see the mass fraction of methane, select methane and display. You can see the maximum mass fraction is in the methane inlet. If you want to see the mass fraction of carbon dioxide, go here, select carbon dioxide and display. You can see the maximum mass fraction of carbon dioxide. So here when reaction goes, you have the maximum product here, and here you can easily see the carbon dioxide mass fraction. You can also see the relative humidity, because we have air and we have water inside this combustion chamber. So here you can see the relative humidity of water vapor. You can also see the enthalpy of methane and the amount of energy being produced by the combustion. Here you can also see some of the reaction properties. For example, turbulent rate of reaction. So here you have the maximum turbulence at the end of your nozzle, rate of heat of reaction. So you can see the maximum heat of reaction. So this kind of indicates the flame formed where the maximum heat has been generated. So this is the flamelet model, and you can see the trace of the flame also. So with these options you can see lots of different parameters and different features of combustion. You can also model NOx emission. You can model different types of air fuel mixture. All you have to do, you have to go to the model, species transport, and mixture material. You can change here the mixture material. Then you will see how to change these parameters. And this is pretty much the basic of combustion simulation, which is a very simplified model. For complex combustion simulation, we have premixed, non-premixed, and partial premixed combustion modeling. We can also see the temperature distribution along the radial direction. So all you have to do, you have to go to new surface, isosurface, select the mesh and z coordinate, compute. Now the range along the z direction is from 0 to 1.81. So we want to see the propagation of our temperature from each and every 200 millimeter apart. So first of all, select right point 2, and this is z coordinate 1, create. Select 4.4, this is z coordinate 2, create. Select right point 6, this is z coordinate 3, create. Right point 8, this is z coordinate 4, create. Right 1, this is the coordinate 5, create. Right 1.4, so this is the coordinate 6, and 1.8, this is the coordinate 7, create. So if you want to see which plane you have created right now, so go to mesh and uncheck all of these, select z coordinate 1, display. You can see here z coordinate 2, here z coordinate 3, z coordinate 4, z coordinate 5, 6, 7. So if you go to the contour, and if you want to see the temperature at all of the z coordinate, so select z coordinate 1, display. You can see here this is the outlet. So as you can move close to the inlet, you can see the temperature change. You can see the change of temperature. We can also create some of the more isosurface, for example 1.6, create. This is 8, display, and 1.2, create, close, and display. So here you can see the temperature distribution, the radial temperature distribution for our combustion. If you want to see with our center plane, you can easily see this. So here now you have a nice 3D image of your combustion, how the axial temperature distribution and the radial temperature distribution changes with your distance. So by this process we can do lots of post processing we can calculate a lot of interesting parameters, and we can easily see how the combustion simulation is modeled in ANSYS Fluent. So in the next tutorial we will see some multi-phase flow problem. Thank you.